Hey everyone, welcome to another video. Today we're going to be tackling three ideas: infinite limits, limits at infinity, and vertical and horizontal asymptotes. So the first definition is basically infinite limits. Infinite limits is when the answer of our limit question leads us to infinity. For example, if we have limit as x is going to 1 for, let's say, x squared minus plus 2, for example, over x minus 1. The first thing that we notice is that if we try to substitute x with 1, then I will have 1 plus 2, which is going to be 3 over 0, which is going to lead me to infinity. Okay? Now, here's the thing. You have to note to yourself that x squared plus 2 over x minus 1 is not simplifiable. You cannot do anything that makes this equation easier to read or manipulate it to make it solvable. So we must take it from both sides. So limit as x is going to 1 minus for x squared plus 2 over x minus 1. When we want to substitute 1 minus instead of x right now, we can substitute it with 1 in the numerator, but in the denominator, we should substitute it as 1 minus. So it would be 1 to the power of 2 plus 2 over 1 minus 1, which is going to be 3 over. Now, 1 minus is basically 0.999, right? And minus 1, it means it's going to be a negative number. That means it's going to be 0 minus. So 3 is a positive number and 0 minus is a negative number, which is going to lead me to negative infinity. Now, similarly speaking, limit as x tends to 1 plus x squared plus 2 over x minus 1. Replace it. So we're going to have 1 plus minus 1, which is going to be 3 over 0 plus this time. Now, 3 is a positive number and 0 plus is a positive number. Therefore, I will have positive infinity. Now, we're going to connect the infinite limits with the vertical and horizontal asymptotes. And we're going to say a rule that from now on we're going to use. Every single time x is going to a value, to a number, okay, and it's giving me infinity, this results with x equals to 1 is a vertical asymptote. And the meaning of the word vertical asymptote, it means like if we are going to draw the function itself, at x is equal to 1, there's going to be a blockage. And I will show you just right now what it means. So x squared plus 2 over x minus 1. So you can go to Desmos. And type in x squared plus 2 over x minus 1. Notice over here that the function, this is where x is equal to 1, right? So in the middle, the function over here is approaching 1. However, it never touches it, even if you go down all the way. So even if you go down, let's say, to negative 60, you can see that it will never touch 1. Similarly, if you go up, it will also never touch it. Now, as you can see over here, 1.03, it's going back, and it will never touch the 1. Now, here's how you need to understand it in order for you to know how to even draw the graph. If you look at our answers, at 1 minus, the function was going to negative infinity. So go back to the graph. At 1 minus, it means we're moving from here. This is 1 minus. The closer we get to 1 minus, which is 0.999, the y value is decreasing immensely. So this is why it confirms our answer for it to be minus infinity. And at 1 plus, it was positive infinity. And if you notice over here, the closer we are getting to 1 plus, which is like 1.00001, the y value is increasing immensely. So this is how we confirm that our answers are correct. And this is basically the vertical asymptote. So it was like something like this, right? Was it like something like this? Yep. Hold on. Oh, did it the other way. So it was like this and like this. Anyways, now we're going to go to the limits at infinity. We spoke about the vertical asymptotes, which are tied to infinite limits. So your guess is correct. Limits at infinity will represent the horizontal asymptotes. Let's say we have limit x is going to positive infinity, x squared plus 2x plus 3 over x squared plus 2x minus 3. The rule is very simple. When x is going to an infinite number, okay, when x is tending to an infinite number, we can literally ignore the entire function and we can only take the highest power on the numerator over the highest power of the denominator. So it would be x squared over x squared, as limit is going to positive infinity. And then x squared and x squared will cross each other out as simplification, and you're going to be left with 1. Now, as limit is x is going to negative infinity, we are going to get the same exact answer because we're going to ignore the entire function and we're going to only consider the highest power on top and on the bottom. So now we're going to be left with also 1. Therefore, we will say that y equals to 1 is a horizontal asymptote. So I just want you to understand something, that when we were talking about the vertical asymptote, x was the number, therefore x was the horizontal asymptote. Vertical asymptote. And now when we're talking about horizontal asymptotes, it was the answer, and the answer is always of the form of y, because the general term for limits, limit as x is going to a f of x, and the answer is always y. Therefore, over here, y is equal to 1 is a horizontal asymptote at both infinities. So this is the connection between vertical and horizontal asymptotes. I will show you this function over here. So it was x squared plus 2x, plus 2x plus 3 over x squared plus 2x minus 3. Notice over here that the function, the horizontal asymptote, y is equal to 1, the function is not even touching 1 and the y value. As x is going to negative infinity, the y value is getting closer and closer and closer to 1, but it will never touch it. It's slightly above over here. And at positive infinity, so over here we're looking at negative infinity, so at positive infinity over here, same thing. You might think it gets really, really, really close, but it will never touch it. So this is the meaning of positive and horizontal asymptotes. Now, some frequently asked questions. So frequently asked questions, FRQs. Sometimes you could have two different, you can have two different horizontal asymptotes. I'm going to call them HAs. For example, at negative infinity, you could have a horizontal asymptote, for example, as y is equal to 2. And at positive infinity, you're going to have horizontal asymptote as y is equal to negative 2. So this is something that you might see later on, and we can give more videos about that with more examples. You could also have two different vertical asymptotes. For example, if you have a function, for example, let's say f of x is equal to 1 over x minus 1, x minus 2. Over here, x is different from 1 and x is different from 2. We are going to have vertical asymptote at 1. We're going to have a vertical asymptote at 2 as well. So what you are going to understand is the fact that vertical asymptotes and horizontal asymptotes, they exist according to the domain of the function itself. This is it for this lesson. We are going to end it right now to not overload with information. If you have any questions, please leave it in the comments, and thank you all.